Here. Okay, so it will also increase. Second is increase in temperature. If you will increase the temperature, what will happen? Tell me. Your evaporation will increase.
The evaporation will increase.
Right. And what about humidity?
Evaporation also will increase.
Yeah, if we will decrease the humidity, then your evaporation will increase. But if you will increase your humidity, then your evaporation will decrease. Right?
Yeah.
And increase in wind speed, your evaporation will increase. So these are the things which we know. But we will be doing the things like in detail. Like if you get questions for 2 or 3, like 3 or 4 marks, how you're going to write. So first thing is that, ma'am, increase in surface area. So we know that evaporation is a surface formula. Just remember 2 things. Just write it down. Boiling is a bulk phenomena. Okay. And evaporation is a surface phenomena. Bulk phenomena is, for example, you want to boil something. So you need at least good quantity, 1 liter, half liter, like this. You cannot boil a single drop, right? So that's why it's a bulk phenomena, but evaporation is a surface phenomena. Why? Because you need a surface for evaporation, right? In air, no evaporation will take place. You need some surface. From surface only evaporation will take place, right? So that's why just write it down. Boiling is a bulk phenomena and evaporation is a surface phenomena. Just write it in box. Good evening, Adil. How are you?
Fine.
Okay, so Adil, where were you in the previous class?
I was not in the country. I mean.
Okay, so do watch the previous recording, Adil, because that was very important because we also did numericals. Okay?
No.
So watch the recording and I'm expecting from next time you will be regular, right? Yes?
Yes.
Oh, good. So basically today we are doing evaporation, right? So what is evaporation? You already know. When your liquid changes into gaseous form, that is known as evaporation, right? So today we are doing how you, like when your evaporation will increase. Okay. So we have 2 things. Like we have various factors like surface area, temperature, humidity and wind. So we will look on that how, if we will increase the surface area, then what will happen to evaporation? The rate of evaporation will increase or decrease. Okay. So just remember 2 things. We have boiling as well as evaporation. So boiling is a bulk phenomena and evaporation is a surface phenomena. Okay. So Adil, you are going to make notes from here only. Like I'll tell you from where you need to make notes. So you can leave, I guess, 2 pages or 3 pages, and you can start. Okay.
Okay.
And when you will watch recording, accordingly make notes. Okay. And student, today I'll share you an assignment which will be MCQ for this chapter. It will have 10 to 15 questions, maybe 10 or maybe 15 questions for this chapter. So I'll ask your counselor to upload it in your portal. So check your portal and complete that assignment. Okay.
Okay, ma'am.
Okay. So let's just start. Then this boiling and this.
Yes, ma'am.
Okay. So let's just start. Okay. So first thing is that, ma'am, increase in surface area. If you will increase the surface area, for example, this is the surface area. Now you increase your surface area. Okay. So if the surface area is increased, the rate of evaporation increases. Okay. Why, ma'am? For example, while putting clothes for drying up, we spread them out. Okay. So, ma'am, yes, with the increase in surface area, your evaporation increases. Okay. Next, an increase in temperature. With the increase in temperature, more number of particles get enough kinetic energy to get into vapor states. That's why with increase in temperature, your evaporation increases. Okay, clear? So
Yes.
if you will get the question like why, see, with increase in surface area, your evaporation will increase. With increase in temperature, like temperature means if there will be more, just take the example of drying your clothes. If you will spread your clothes, like one clothes is here, other is here, then of course evaporation will be faster. Similarly, if there is more warm, there is increase in temperature, also evaporation will be high. And if wind is blowing, okay, the increase speed of wind is high, then also your evaporation will be high. Okay, so first this, and second, ma'am, why there is increase in temperature? Like why with increase in temperature evaporation increases? So with increase in temperature, more number of particles get enough kinetic energy, because as I told you, na, with increase in temperature, kinetic energy increases. So they get more kinetic energy and they easily and quickly change into vapor state. Next, decrease in humidity. Humidity, it's a inverse relation. So what is, first of all, what is humidity, ma'am? So humidity is the amount of water vapor present in the air. So the air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. Okay, so it's like air cannot hold so much like infinite amount of water vapor. No, air can hold only particular amount of water vapor. Therefore, if you have more load, okay, if humidity is basically the amount of water vapor. For example, if you have 100 water vapor, okay, and similarly you have 50 water vapor, so this you can easily move in this state because you have less water vapor, right? But if you have more water vapor, it will be somewhere heavier, so you won't be able to change your state. So when there is decrease in humidity, when there is low humidity, then evaporation is faster. But when there is high humidity, that means the weight of air is high because air has more particles, then the evaporation rate will be very slow. Got the point?
Yes.
Yes, ma'am.
Okay, if you have more humidity, like more water vapor in air, of course it is heavier, so I cannot easily change my state, right? But if I have less water vapor or less volume in me, then I can easily change. So this is the reason. Next, an increase in wind speed. So it is very common observation that the clothes dry faster on the windy day with the increase in wind. So why? With the increase in the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. So basically what happens, these are the clothes. Okay, so whatever water vapor is present around, with wind they travel and they move. So somewhere your clothes will dry up faster. Clear?
Yes,
Yes.
ma'am.
Okay. So now how you're going to make your notes? Okay. So first of all, you will write hashtag the rate of evaporation increases with. Okay. Then you will write first point, increase in surface. Just a minute. First you will write increase in surface area. Okay. So you will write if the surface area is increased, the rate of evaporation increases. Still here. Then second point, this increase in temperature. With the increase in temperature, more number of particles get enough kinetic energy to get into vapor state. Therefore, this is a sign of therefore. Okay. Therefore, evaporation increases with increase in surface area. You will add your line over here. Okay. Third, decrease in humidity. So first of all, you will explain what is humidity. So humidity, and after that you leave one line. If you then you will write here. Okay. Next, fourth, increase in wind speed. So you will write with the increase in the particles of water vapor away from the decreasing the amount of open. Therefore, evaporation increases with increase in wind speed. You will add the line over here. Okay. Clear?
Yes, ma'am.
Okay, for third point, the air around us cannot hold more of the definite amount of water vapor at the given temperature. Okay. Okay, decided this is fine. students, let me know once you are done. Okay.
Yeah, I'm done.
Done, ma'am.
Okay. Okay. See, one more thing you have to remember that, for example, these are my clothes. Okay. So whenever evaporation will take place, what will happen? The surface will become cooler. Okay. The cooling effect will be, for example, whenever we apply thinner. Okay, the nail paint remover, especially for girls. So whenever you apply it, so what happens basically, your whatever your material is, it will somewhere go away and it will leads to cooling effect, right? So the question is, how does evaporation cause cooling? Okay, so in an open vessel, the liquid keeps on evaporating. Okay, the particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. So evaporation leads energy. So what happens basically, your liquid is being converted into gaseous form. Okay, so this liquid is losing energy and this gaseous form is gaining energy. So the particles of liquid absorb energy from the surrounding to regain the energy lost during the evaporation. This absorption of energy from the surrounding make the surrounding cold. Okay, so basically what happens, in order to convert liquid into gaseous, you need to boil it. Okay, so what happens, the energy is basically, for example, this is a beaker. Okay, you are going to heat the liquid to convert it into evaporation like the gaseous form. So what happens, this liquid is losing energy. So what he will do, he will take energy from the beaker. Definitely this doesn't happen, I'm just taking an example that whatever energy liquid lost, he will take energy from the surrounding. And when he will take the energy, of course the energy will be heat energy. Why? Because you are heating it, only then it is being converted, right? So when heat energy from the surface, he will be taking, and this will be cooler because heat energy is already liquid has taken, so that's why the surface will be cooler. Clear?
Yes,
Yes.
ma'am.
Okay, good. So now you will just write the question, how does evaporation cause cooling? Okay, so you will write this, the particles of liquid absorb energy from the surrounding to regain the energy lost during vaporization. This absorption of energy from the surrounding make the surrounding cold.
Done, ma'am.
Done.
Oh, okay. Hello, Jasleen.
Hi, ma'am.
You are not audible. We covered lots of the
Leaving.
topic. Yeah. So you joined late. So you will watch the recording so that you can cover the previous thing. Okay.
Okay, ma'am.
Now, student, next is what happens when you pour some acetone. Basically, this is your nail polish remover on your palm. So similarly, right? So what happens when you, for example, this is your hand. Okay, you are going to pour it. So what will happen? The particles gain energy from your palm. The particles of acetone, they will get energy from your hand. So of course, what will happen? Your hand, he is releasing energy, right? So your hand will become cooler. Okay, the particles gain energy from your palm or surrounding and evaporate, causing the palm to feel cool because they are going to take energy from you and the surrounding. So the area from where the particles take energy, that area become cooler because they are going to take the heat energy, right? And next is after a hot sunny day, people sprinkle water on the roof of or open ground because the large latent heat of evaporation help to cool the hotter surface. Okay, this is also an example. So what will happen? Basically, this is the land or the roof. So you're going to pour water. So what will happen? The water particles will take energy from your roof, and your roof will become cooler or hotter. Adil. For example, this is your roof. You are going to pour water over here. So the water particle will take energy from your roof. So your roof will become cooler or hotter.
Hotter.
Sorry,
Hotter.
hotter.
Cooler.
It will be something either hotter or cooler. Yeah. Who is going to answer? Jeba. Okay. Jasleen, you want to try? The same example I gave for palm. That, for example, this is your palm. You're going to pour the acetone over here. So the acetone particles will take energy from your palm and your palm will be cool. So same like this. Over here, what you are doing, this is your roof. You're going to pour water particles over here, water. So water particles will take energy from roof. So what will happen to roof? Cool or warm? Hot or cool? Tell me. Same example. What happened to your palm? It became cooler or it became hotter? Tell me, students.
Cooler.
Yeah. So what will happen to your roof?
Cooler.
Yes. Why? See, this is very, very simple. See, for example, any surface area. If you will pour something on that surface area, so the particles of the thing you are pouring, they will take energy from that particular area. And when they will take energy, of course, they will take heat energy from this area. So heat energy is something moving out. So the remaining will be only cooler area, right? So that's why the surface will be cooler. Okay, so whenever you are going to pour something. So this is what you have to remember, very important. Okay. Next is after a hot sunny day, people sprinkle. Sorry, we did it. Can you cite some more example for daily? Okay, just leave it. Now this is very important question. Why should we wear cotton clothes in summer? So during summer, see, this is your body. Okay, so cotton is a good absorber of water. Okay, so this is your body. Your body is somewhere heat up due to summer. So when you will wear the cotton clothes, now this is your body. Now you are going to wear cotton clothes. So what will happen? Cotton clothes will absorb the heat from your body and your body will feel cooler. Okay. So during summer, we perspire means you sweat more. Okay. Because of the mechanism of our body which keeps us cool. Okay. So basically what will happen? The particles of the sweat particles, they will move out from your body and cotton will absorb it and leaving your body will feel cool. Okay. So what happens? The particle at the surface of the liquid gain energy from the surrounding or body surface and change into vapor. The heat energy equal to latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, being a good observer of water, helps in absorbing the sweat and exploring it to the atmosphere for easy evaporation. Clear?
Yes.
Right?
Yes, ma'am.
Yeah. So why should we wear cotton clothes first thing? Because cotton is a good like is a good absorber of water. So basically, the cotton will absorb the particles, like the sweat particles, and because when he will absorb all the particles, then your body will feel cool. Okay, so now you will write why should we wear cotton clothes in summer? Okay. Then you will write cotton, being a good absorber of water, helps in absorbing the sweat and exploring it to the atmosphere for easy evaporation. Clear?
Yes.
Jaslyn finished, and what about others? Done?
Done, ma'am.
Yes.
Okay. Okay, now last, why do we see water droplets on the outer surface of glass containing ice cold water? Okay, so I hope you people, whenever you take a water bottle from your refrigerator, after some time you can see the particles over here. Okay, so what happens? Let us take some ice cold water in the tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in air on coming in contact with the cold glass of water lose energy and get converted into liquid state, which can be seen as water droplets. So basically what is happening, the particles which are present in the air, when they come contact with the glass water, they lose energy and somewhere they get converted into the water droplet. Clear? Yes, no, maybe?
Yes.
Yes, ma'am.
So you can get the direct question over here. We'll write why do this question, and the answer will be from here. The water vapor present in the air on coming in contact with cold glass of water lose energy and get converted into liquid state, which we can say as a water droplets.
Done.
Girls done? Adil is done?
Yeah.
Yes, ma'am. Yes, ma'am.
Okay, good. Now, basically the last topic of this chapter, okay, which is like, see, you have already done the three states of matter, right? First, solid, liquid, and gas. Now, this is your fourth state, and this is your fifth state, okay? So, fourth state is plasma, and your fifth state is Bose-Einstein condensate, which is basically BEC. So, you are going to write only few points about this, okay? I think over here, like few points, yeah. So just few points about it. So first of all, what you will write? You will write the heading. Just write the heading first. Just give it a heading. States of matter. Okay, two more states of matter. Two more states of matter. Okay. First you will write plasma and second you will write BEC, which is Bose-Einstein condensate. Okay. Clear?
Yes, ma'am.
Okay. So you're going to write 2-3 points about plasma and 2-3 points about Bose-Einstein. So first you will write the state consists of super energetic and super excited particles. So they are very energetic as well as excited. Okay. These particles are in the form of ionized gas. Okay. And next you will write this. The plasma glows with a special color depending on the nature of the sun. Okay. And the sun and the stars glow because of the presence of plasma in them. Okay. This. And one more thing. The fluorescent tube and neon sign bulbs consist of plasma. These 4 points you are going to write. Okay, first, the plasma consists of super energetic and super excited particles. Second, these particles are in form of ionized gas. Third, the fluorescent tube and the neon signs consist of plasma. Fourth, the plasma glows with a special color depending on the nature of the gas. And fifth, the sun and stars glow because of the presence of plasma in them. Okay. And about Bose-Einstein condensate, I hope these points are clear, right?
Yes, ma'am.
Yes.
Right. Okay. Now you will write about that the BEC is formed by cooling a gas at extremely low density. Okay. And then you will write. I think that's enough. Yeah, that's enough. Okay. Clear?
Yes, ma'am.
And write one more point that Albert Einstein predicted the new state of matter. That's why it's Bose-Einstein. Okay, just write till here. The first you write fifth. Albert Einstein predicted the new state of matter, or you can say this state of matter. Okay, and then this.